All right, good afternoon. So, I checked your work on compound interest. Looks pretty good for the 5 of you that did it. That means that a whole bunch of you are not doing it. Remember, our last two summatives are going to be on this stuff right here, this financial stuff, and the other part is going to be on some statistics stuff. So, the end is near, I know. The light is at the end of the tunnel, and hopefully it's not the train coming at you. So, yeah, we're almost there. So let's dig in. A couple more weeks and we'll be out of here. All right, so today we're going to talk about annuities, which is just another way of investing money. And so here's a definition for an annuity. So an annuity is a type of investment that involves a sequence of equal payments made at equal time periods that also accrues interest. So one of the ways that a lot of people involve themselves with annuities is through retirement accounts, and retirement accounts generally come out of, or money for retirement accounts generally come out of their paycheck. If they get paid every week or bi-weekly, then this money is going to go in. So it says at equal time periods, so every week or every 2 weeks. Sometimes it's every month or something like that, but whatever. It always goes into the same time, and and each payment is the same. So if you're going to put in $100 every week, well, that's what it's going to be for the time that you're investing. It's always the same. And we're also going to be gaining interest here. So an IRA, individual retirement account, is an example of an annuity. Okay, let's get right onto the formula here. And so you can see that the formula here has a lot in common with our previous formula, which was for compound interest. So you still got A, which is the amount at the end, equals P, which is the initial investment, the principal, times 1 plus R over N to the NT. All of that is all the same as it was before, only now we're going to subtract 1 and we're going to divide by R over N. And so what's happening here with an annuity is we are not only gaining interest, because we have an interest rate and we're going to be leaving money in there for a while, but we're also depositing money let's say every month. So every month you deposit some more money, and as you're depositing more money, you're getting more interest because you are depositing more money. So the interest isn't only on what you deposited. The interest isn't only on what you deposited plus the interest. The interest is on what you deposited plus the interest plus all of the new money that you put in. So it's a little more complicated, so we need a more complicated formula. So here is our first example. I think I only got 3 today. So you deposit $3,000 into an IRA at the end of each year. So this is kind of a simplified problem, just once a year. For 40 years, the interest rate is 8%. How much do you have after 40 years, and how much of that is interest? So easy enough, you just plug the numbers into the formula here. So we're just going to do that. So we get A equals the principal, or the payment in this case, is going to be 3 G's. So $3,000 times 1 plus the interest rate is 0.08. Number of times per year is 1. And we have to the NT, well, N is still 1, and T is 40 years, so we got 40 right here. And we're going to subtract 1. And we divide all of that by that. So 0.08 divided by 1, of course, is just, well, 0.08. So I'm just going to put 0.08 here. So then we're just going to do the work. And this will be a quick and easy problem. So 1.08 to the 40th power equals 21.72 minus 1 is obviously 20.72. So now we got 3,000 times 20.7245. 20.7245 divided by 0.08. So as you can see, this is going to be a lot of money. So we're going to multiply that by 3,000. 3 equals, divided by 0.08 equals, and we have $777,000, or $169, and how many cents? 56 cents. So this is how much we have at the end of the 40 years, which is not too bad. You know, just dropping in $3,000 every year for 40 years. That's pretty good. And obviously, we're going to gain a lot of interest out of this. So let's figure out how much interest we actually gained. So we made 40 payments of $3,000. So 40 times 3,000, 1, 2, 3, equals 120,000. I don't think I need my calculator for that. So if we want to find our interest, we just subtract what we paid in, 1, 2, 0, 0, 0, 0. And I should probably show you that because you can't see what I'm doing. So in order to find the interest, we're just going to subtract $120,000. So 777, 169.56, and 657. So the interest we made is $657. Sorry, $657,169 and 56 cents. So this is our interest rate here, and this is the amount of money that we had at the end of the 40 years. So annuities are obviously a good deal here because you end up making a crap ton of interest for payments over the course of 40 years or 30 years or however long you're investing your money for. So that was a little easier problem because we were only investing once a year. I left some space up there to do some more work, but you know, well, we did the work on the bottom of the other page. All right, so let's say at the age of 30, you deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much do you have at the age of 65, and how much interest did you make? So let's find out. So again, we have our formula here, A equals P, and then we got 1 plus R over N to the NT. That's all the same as it was before. We're just going to subtract 1 and divide by this bit right here, R over N. And just plug in the numbers. So $100 times 1 plus interest rate, 0.095, divided by 12, because we're going monthly here. Oops, I forgot my parentheses. To the NT, so that's N is 12. NT is the number of years, which is 30 years. Oh, no, hold on. So we got 30 years. This is when we started, but we're going to age 65, so that's obviously going to be 35 years. We'll subtract 1, and we'll divide by 0.095 divided by 12. So just grinding right through here. So we got 0.095 divided by 12 plus 1 equals to the, we'll raise this to the 12 times 35 power. And that gives us 27.4374. Minus 1 is 26.4374. So we got 100 times 26.4374 divided by whatever 0.095 divided by 12 was, 0.007916 repeating, 0.007916 repeating. And when we're dealing with big numbers, we should really be including whole bunches of decimal places right here. And you know, you have a calculator, it's not like you're doing it by hand, so you know, just include those extra decimal places. So we're going to do so subtract 1 times 100, and then we divide by that, 0.00791, and a whole bunch of sixes, equals 333,946. So 333,946.30. So that's what we have at the end of our 35 years, and so you can see that even those 5 extra years makes a very big difference. So the moral of the story here is the sooner you start investing for your retirement, the better it is for you. More time means significantly more money. Okay, so there it is, $333,946.30. And again, we want to find out how much interest we earned. So that's pretty easy. We're going to deposit $100 a month. So that means we're going to have $1,200 a year times 35 years. So 1,200 times 35 equals 42,000. So we will have deposited in there 42,000. And this is going to be our interest. Oops. So 333,946.30. So obviously we're going to have 946.30 here. And that's going to be a 1. And so this is going to be 13 minus 4 is 9, 29. There we go. So $291,946.30 in interest that we gained just by letting the compound interest do its thing. Okay, so again, just plugging the numbers into the formula. It is really simple stuff. Okay, so this is really our last example right here. So parents want to have $100,000 for a college fund for their child when the child, turns 18. They expect to earn 9% compounded monthly. How much should be deposited each month from birth? So again, we're just going to use that same formula, only instead of solving for A, we're just going to solve for P. The book actually rearranges the formula for you, but why bother? Just memorize one formula and that's it, or have one formula to work with. Okay, so we're just going to plug the numbers into the formula and be done with it. So we have, again, just our formula right here. A equals P times, oops, I'll bracket there, parentheses, 1 plus R over N to the NT. Again, that's all the same as it was before. We're just going to subtract 1 and divide by R over N. It's just the same. Okay, so we're going to have an amount at the end this time, and all this other stuff, we're just going to need to find P. The amount at the end that we want is 100 Gs, which, by the way, unfortunately, is not going to be enough to pay for college 18 years even from now. And so we have P, which we don't know. And we got 1 plus the interest rate, 0.09. And they are depositing or compounding monthly, so that's a 12 there. And 18 years from now, so we're going to do monthly, that's the N times the T, minus 1, bracket, and 0.09 divided by 12. And so we just do the stuff here. So 0.09 divided by 12 equals, plus 1 equals, so that's 1.0075. So we know we're going to be dividing by 0.0075, which is definitely a little nicer than the other number that we had to work with. We're going to raise that to the 12 times 18 power, which is 5.022 blah blah blah, minus 1 is 4.02264. So we got P times 4.02263, and make that an 8, and we want to have 100,000 at the end. So there it is, we got 100,000 at the end. So we're going to multiply by 0.0075, divide by 4.022 blah blah blah, and we have P. So times 0.0075 divided by 4.022, 4.022638 equals $186.44. So P equals $186.44. So if a child was born today, 18 years from now, if $186.44 was deposited every month for 18 years, at 9% interest, there would be $100,000 left at the end. So, and again, you can do the same kind of calculation here with your retirement. So I would like to have, I don't know, $1 million when I retire at the age of, whatever, 65, and you're 25. So you just plug in all the numbers here and you can figure out, well, how much do I have to deposit every month into a retirement account? So I'll have $1 million when I am retiring. By the way, $1 million is, it's more than it sounds like a lot, but when you have to live on $1 million from the age of 65 until you're not living anymore, that is maybe not a lot of money. So anyway, I wish we were in class so we could talk more about this and discuss these things in a real sort of way, have an actual discussion about it. But this is the best we can do in our little Corona school situation. So this is our stuff right here. I'm going to give you a little tiny bit, one example to read on how to read some information about stocks, and that's going to be the whole assignment. So there it is. We're winding down here. So I will see you again on Wednesday. Please make sure you're doing the assignments. Again, this test is going to come up fast. It's going to be next week. And then we get another test on stats coming, like 2 weeks after that. So we'll be done before June 5th, but we got to keep moving, and please move with me so that you don't fall behind, so you don't miss all this stuff, because for a lot of you, this is all new stuff. So I'll see you guys on Wednesday. Be safe.